Okay, so this is on a different day for you, but I'm just going to kind of continue during my conference, finishing this up. I'm going to scroll down, and we're going to finish naming how to go from a name to a chemical formula, which is what we're learning this week, how to go from names to formulas. So yesterday, you should have learned how to do ionic compounds, how to go from a metal and a non-metal, and you cross their charges. That is not anything like what molecular is. Molecular is actually way easier. So we can kind of start with a harder one and then go into molecular compounds that are way easier. You can see there's way less notes because they're pretty straightforward. The hard part about it is people get confused. They'll name them like these ones. They'll use these naming rules, or they'll use these naming rules for the ionic. You just mix them up. So that's the only hard part, is making sure that when it's molecular, you use molecular rules. And when it's ionic, a metal and a non-metal, you use ionic rules, which is what we did yesterday. Today we're doing molecular, which is non-metals and non-metals only. So if it's a bond between a non-metal and non-metal, these are the rules you use. So I'm going to write that here. So molecular is also called covalent all the time. We kind of use those names. Why does my board just shift? It's just so weird. I fix it and then it goes crazy. Okay, so we call it covalent all the time as well. And it's a non-metal. It's just going down. I'm writing in a straight line and it's putting it down. Non-metal between a non-metal. Okay. And try to calibrate it one more time. Even though for me, like y'all are seeing these on different days, I've calibrated this several times already. Okay. Let's give that a go. So we've been calling them covalent. Okay, better. Except for how I misspelled it. Oh gosh. And it's a non-metal and a non-metal bonding together. Okay? All right. Now, when you notice it's a non-metal and non-metal together, how do you notice that? Remember, we just know where our stuff is on the periodic table. Non-metals are across the stair step. So all these guys, if it's a bond between two of those, then this is the way you name it. You literally just use prefixes. Remember, prefixes means you write it before the name. Okay, so it's prefix. And these are the prefixes. You do need to know these. Mono means one. Di means two, because there's usually like two dices in a game. Tri, like triangle, has three sides, means three. Tetra, if you've ever played Tetris, it's all those cubes. Cubes have four sides. Or not really. Squares have four sides. So tetra means four. That's why it's called Tetris. Penta, like a pentagon, has five sides. Hexa, like a hexagon, has six sides. Then we get a little weirder. Hepta, I doubt many of you have looked at heptagons, but heptagons have seven sides. Octa, octopus, has 8 legs. Nono is, again, kind of weird. Probably most of you haven't had a nonagon, but they have 9 sides. And I kind of remember it because 9 starts with N, and so does nona. And then deca, you think decade. So 10 years in a decade, that's what deca means. Okay, now, so there's no crossing of charges. There is no charges. Molecular compounds share electrons. They're not giving and taking. They're not making charges. So how I know how many there are in a compound is that I literally have to be told. I can't write the charges and figure it out. I have to be told how many is in the compound, because you can share in a multitude of ways. So the name has to tell me what's in it. So this says di, this has nothing. One of the first rules for molecular compounds is you actually don't have to have a prefix on the first element if it's just one. We used to write mono, so it'd be like monocarbon disulfide, but they stopped making you write mono on the first element. So for carbon, if there's no prefix in the first one, it's just one. So there's one carbon. And di means two in our prefix. So sulfur becomes sulfide, and that would be a 2. So there's 2 of them. There you go. Then you have dinitrogen. So nitrogen is symbol is N, and 2. There's 2 of them. And then hydride sounds kind of weird. That's hydrogen. Hydrogen becomes hydride, and it says there's 4 of them. Tetra means 4. So it's N2H4. Bam. See how this is much easier than yesterday, as long as you know your prefixes. So we have diphosphorus. So I have P, which stands for phosphorus, and 2. And then trioxide. So tri means 3. And oxide was oxygen. So it's O, 3. P2O3. And then xenon, which is Xe. Xenon is the only noble gas that every now and then makes compounds, because pretty much noble gases don't make compounds, but xenon is one of the weird ones that does every now and then. There isn't a prefix, so it's just one. And then hexa means 6. Fluorides, fluoride is fluorine, so that's F, and there are 6 of them. And that's it. That's how you do it. You just use your prefixes. So molecular compounds are really easy. Again, the hard part is that you're going to want to do, because it's easier, you're going to want to do these to all of them, and then you're going to get a whole bunch wrong. So when it's ionic, when there's a metal and a non-metal, you have to do it the way I taught you before. You have to find their charges and crisscross them to balance their charges. That's just how their formulas are made. They have to be balanced in ionic compounds. Whereas in covalent, it doesn't have to be balanced because they're just sharing. They can share in all kinds of ways. So their names just require prefixes. How can you tell whether you should write a compound formula using molecular rules or using ionic rules? Again, this is it. This is the kicker, and you have to get this now because it's going to stay with us literally all year. Ionic has a metal and a non-metal. Forgot the N. There we go. It has a positive from the metal and a negative from the non-metal. That's what makes it ionic. That's what makes it have ions. You have to do charges, and then you have to crisscross them to get them balanced. Molecular or covalent, either name works, is a non-metal with a non-metal, and they just share electrons, so they need prefixes. So they have prefixes, and ionic has charges, the charges that you write above them and crisscross, okay? Those are the 2 types. The hardest part is just keeping them separate and not swapping them up. Other than that, the molecular is really easy to do. Okay, we are done with notes for the week, guys. Yay!